Hello, everyone, and welcome to this episode of Pod Save Chocolate. My name is Clay Gordon. I'm your host, your moderator. I'm also the creator of thechocolatelife.com. Today, before we get stuck into today's episode, which is going to be talking about quantifying the flavors of cocoa and chocolate, I want to let everybody know that this episode of Pod Save Chocolate, like every episode of Pod Save Chocolate, is sponsored by members of thechocolatelife.com. If you're not a member, please go over there, become a member. If you enjoyed the video today, like the video and subscribe to the channel, right? And so before we jump into today's topic, what I want to do is also point out that this is the homepage of the Chocolate Life right now. For those of you who are watching, this is the homepage of the Chocolate Life right now. If you're listening to this, I put together a post for every single episode. And in that post are the links to resources which are mentioned during the course of the episode. So if you're listening to this afterward and you want to go back and you want to go and review any of the websites that are mentioned, any of the resources, any of the images that are shown, you can go to thechocolatelife.com, click on the Pod Save Chocolate link at the top, and then there you can scroll down the complete list of episodes to find ones that you are interested in, right? And so today, what I'm going to be talking about is I'm going to be talking about a presentation that I am going to be co-giving with my friend and colleague, Zoe Papalexandratu. I met Zoe for the first time in Nicaragua in 2014. She was working with Ingeman. I was working with Ingeman. And we then, our paths crossed again when I retained her to do some work on a project down in Mexico. In the state of Tabasco, again, looking to increase the quality of cocoa so that it was up to export standards, right? And so we're going to be talking, she and I are going to be talking about this topic, quantifying the flavors of cocoa and chocolate. And the real question is, why? Why are we doing this? Why are we talking about quantifying the flavors of chocolate? And then why am I doing this episode? And part of the reasons why I'm doing this episode is so that I can talk my way through. And I can get feedback from you. So no matter where you are, connecting today, listening, go into the live chat on YouTube, go into the comments on LinkedIn and Facebook. Let me know what you think about today's episode. And if you have comments, or just let me know where in the world you're connecting from, and I'll get the shout out up on screen. So if you look at the overview for today's episode, this topic about flavor is something that has interested me since the very beginning. I put out my shingle on the internet at chocophile.com in May of 2001. And before I could do that, I needed to have a rating system, a rubric for saying, this is how I am going to taste chocolate, and this is the score. This is how I'm going to score the chocolate that I give. And even though this is something that I've been working on, and I did come up with a solution back in 2001, it is something that I have been looking at continually for more than the last 20 years. So this coming October, so what is it, about 2 months from today, I'm going to be giving a presentation in Brussels for the British Society of Flavourists with Zoe on this topic of quantifying the flavor of cocoa and chocolate. And what I wanted to do, number one, is to just, I am just really, 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 thrilled to be a part of any symposium program that includes the names on this list, specifically Peter Schieberle, whose work in this area is something I've been following for more than 15 years. So I'm really, really excited. The link to the symposium is on today's post. You can go there. You can find out who the speakers are. You can find out who the speaker topics are, what the speaker topics are, what the topics are. Excuse me. And then this is open to anybody who would like. You don't have to be a British Society of Flavourists member. So if you're in the industry and you'd like to attend this seminar, it's the week before the Salon du Chocolat in Paris. And so, if you're going to be there or you can arrange to be there, you can do so. And so all the information about how to buy tickets and the agenda is all here on this page that I've linked to. And what I also want to do is say that this is a direct follow-up of a presentation that I made last year on communicating the flavors of chocolate and coffee. This was my presentation. I made it virtually last year, but there's an entire episode which is dedicated to the presentation that I made last year at the symposium. And this was more about vocabulary and visualization and how do you talk to consumers opposed to about professionals when you're talking about flavor. And that is what it is that led to this year's topic. Now, I worked with Zoe to create a topic that we both agreed with, and we settled on that topic before we knew what everybody else was going to be talking about. And so to some extent, what we're going to be talking about is going to be a reaction to what everybody else says, right? Which is going to be really, really interesting. I love being the last presenter of the day, so you do have a chance to talk with points. Talk to points that the other speakers made, which is one of the things that I love to do, right? But again, my reason for doing this today is to talk this through. So obviously I'm talking it through with Zoe, but I want to talk it through with you. I want you to let me know what you think about this. I want you to tell me if this is interesting, if these topics are interesting to you. It's part of my process often to hear myself say things out loud. When I hear myself say things out loud, it has a different impact on me internally if I'm just reading, right? And so I get a different sensibility. So that's why I'm going to be talking through this today. And so again, we're going to be talking about, I think Zoe and I are going to be talking about why are we doing this? There's more to the flavors or understanding the flavors of cocoa and chocolate than just analytical chemistry. And so, one of the ways thinking about analytical chemistry is, I have a spreadsheet, and on this spreadsheet, it's called Chemistry of Cocoa. What I've got here is I've got a list of many of the chemicals that if you were to run a prepared cacao sample through high performance liquid chromatography, HPLC, or in gas chromatography, what you do is you'd find here are the chemicals that you'd find, right? Not in all samples, because different genetics grown in different parts of the world, in soil that is different, will have different not only individual chemical constituents, but the balance of constituents, of which are more present than others, will be different. But I thought that this would be interesting. You can download this spreadsheet. It's not mine. I didn't come up with this. I don't exactly remember where I downloaded it from originally. But if you are interested in just getting an idea about what some of the chemicals are that can be found, let me scroll this over just a little bit. Some of the chemicals that can be found in chocolate or in cocoa, then this provides a list, and there are something like over 300, about 300 chemicals that are listed on this sheet, and it's a good place to provide so from an analytical chemistry point of view, this is a starting point that we can go look at, right? But what I want to do next is say, okay, what do we do with that? What do we do with that analytical chemistry? It is a foundation for something, right? And so back in 2012, I first presented to the Experimental Cuisine Collective at New York University, and I forget the school at NYU that this was before, but the Experimental Cuisine Collective, I was asked to do something, and I created something on how chocolate gets its taste. And as a part of that presentation, this is an image up on the screen. I'm going to be talking through that image, so that if you're just listening to, you get an idea. But again, go to the post. This image is embedded. You can take a look at it more closely. I created something that I called the flavor equation for chocolate. And it basically starts as the flavor of chocolate. So the F, right? The F of chocolate is modified by a bunch of things, right? So the first one of the contributors to flavor that we need to look at is the genetics of the tree. And the genetics of the tree represent potential. So different genetics have different basic profiles of the chemicals that are in the bean. So for example, if you have a white bean cocoa, it is missing a lot of the chemicals that give cocoa beans the purple color. And the purple color tend to be anthocyanins, procyanidins. Those kinds of chemicals not only contribute to color, but also to perceptions of bitterness. And so the genetics represent the potential. Now that potential represented by the genetics is modified by some factors. There are the factors of terroir. So terroir conventionally includes things like what is the chemical composition of the soil, how much rain there is, how much sun there is, when in the year the rain happens, where is the cacao planted, and things like that. So those are things which are normally considered to be terroir. And so the genetics are modified by the terroir. Take the same genetics, plant them in different places, you are going to get different chemical compositions within the bean. Right? From then we need to look at, so those two things are also then modified by agronomic practices. So are the trees, number one, healthy? Are they fertilized? Is there a pruning program? So we can modify the terroir. And what we might do is we might say that certain practices with respect to pruning and fertilization actually get subsumed into the terroir category. So we're thinking about terroir a little more broadly, right? And then all of that gets modified by harvesting and then post-harvest practices. So we may harvest and then leave the pods unopened for 24 hours, then open them and put them in a sack and let them drain for another 24 hours, and then put them into a fermentation pile. So pre-drying, as that's sometimes called, might be a part of the local terroir, the practices of post-harvest processing. Right? But the genetic potential represented by the trees, right? And I should actually say that that genetic potential is also modified by pollination. So depending upon the genetics of the tree that donated the pollen to a particular pod is going to have an influence on the flavor potential of the beans from that pod. So it does get even deeper. I mean, it's very, very high level understanding. But we do need to think about the genetics of the tree, modified by the terroir, modified by agronomic practices, modified by post-harvest processing. When we get done, we end up with a dried cocoa bean, from a wet cacao seed to a dry cocoa bean. Right? And then from there, the potential, which was represented by the dried bean, is modified by the manufacturing processes that go through. So for most people, the most important manufacturing process is the first step, which is going to be roasting. So depending upon the roast profile, which will change depending upon the genetics of the bean, and all of the things that are on the farm, we're going to convert the chemicals which were created during the post-harvest process into different chemicals, right? And so let's step back a little bit. So what is fermentation all about? So fermentation is, well, what is it about? It's an attempt to change the chemistry of the cocoa bean and to in order to be able to influence the chemistry of the bean and therefore influence the flavor of the chocolate that is made from the bean. So fermentation takes very, very complex chemicals, proteins, for example, breaking them down to simpler amino acids. It will change long chain sugars into short chain sugars. There is a pH. There's an effect on the pH of the bean during fermentation that can be monitored so that we understand fermentation better. Right? But the goal of fermentation is this conversion of complex chemicals, which may not be as available to roasting, right? To changes in roasting, to break them down into simpler and more chemicals which are more available to modification during the roasting process. So it is not true that an unfermented cocoa bean that is roasted will not generate a chocolate flavor. In fact, what you'll do is all you'll get is a basic monotonic chocolate flavor out of that bean. All of the flavors that cacao experts, if you want to call them that, connoisseurs, treasure, the fruity flavors, the floral flavors, all those other non-cocoa flavors that are in chocolate come from the fermentation process that makes these chemicals more available to the chocolate, to the chocolate maker. And through the manufacturing process, is what they can do is they can alter the chemicals that are in the beans, which will alter the flavor of what it is that we're tasting. So I'm making this introduction to all of you. I don't know how many professionals there are who are watching this. I'm talking this through, and I'm going to say, okay, what do I need to take from this as a part of my presentations? Because I will be speaking with professional flavorists, and I don't know how many of the people in the audience, right, are actually familiar with post-harvest processing and what's going on. I mean, are they waiting until they get cocoa products or chocolate products in their lab, and they might have chemicals that they add, or they're looking to alter the chemistry of what they have, not really knowing much about what it is that's going on before the product ends up in the flavor lab. So that's one of the reasons why I want to go do that. I want to go talk about that. So that's the flavor equation, that the flavor of finished chocolate is based upon this series of steps which modify the genetic potential, which is represented by the beans. And so from that, we can go all the way back to Montemayor in 2008 and talk about the genetic distribution. We thought it was just these 4 varieties, Criollo, Forastero, Trinitario, and Nacional. And in 2008, we learned that it's a lot more complicated than that. And we can now use that genetic information in lots of interesting ways. All right. Fermentation is also really, really interesting. I'm spending a lot of time on this because for many foods that we consume, fermentation is very highly controlled. So if I'm fermenting an industrial or commodity beer, for example, I'm always going to be using the same strain of yeast. And I take real care to make sure that my yeast strain is pure. I'm going to be fermenting wine the same way. All right. Coffee is wild fermented. Cocoa is wild fermented. There's not a whole lot of inoculated fermentations in it. Whereas with if there is a yeast strain or a mold strain, there is a bacterium which is introduced into cheese, it is going to be a carefully controlled strain and inoculated. So chocolate and coffee are different from most of the other foods because of this fermentation aspect, which again, I'm not certain, exactly how the professionals who are going to be in the audience have considered all of this. I'm not entirely sure, from a flavorist perspective, what their background is. And so, we'll have dinner the night before, and I'll be able to ask some of those questions, and then I will be modifying my presentation sort of on the fly to make sure that happens. So after that, what we need to do is understand that, chocolate is a complex food, right? And the slide that I'm showing has a couple of bullets, one of which is that there are over 750 distinctly identifiable compounds in many chocolates. Right? Not all chocolates, and some chocolates are going to have more. Only 25 of those 750, right, are needed for a baseline cocoa aroma, the smell, right? And only 15 are needed for baseline cocoa taste. And so those are the chemicals that interact with the chemoreceptors on the tongue, sending signals to the brain. And it is the interaction between the aroma and the taste and other environmental factors such as temperature, which affects texture and mouthfeel, for example, which make up the sensation we call, which make up the full experience that we call flavor. Really important, really important. And it's also really important to know that unlike some other flavors that are out there, there's no single chemical compound that we know about yet. And this is back in 2012. I don't think that it has been updated to say that there's anything new since then. Carries what we think of a typical cocoa sugar, a signature. So what we think of as cocoa flavor or chocolate flavor is always a combination of chemicals. So what are some aroma flavor chemicals that are involved in this? And I mentioned 3. Right. And I got these 3 from that spreadsheet. And then I went to look up what the chemicals were in a flavor database. And so we have something called alpha amyl cinnamyl acetate, and its aroma, right, is floral, jasmine, chocolate, leather, fruity, balsam, spicy, cinnamon, so like cinnamon. And the flavors are, or actually should be taste rather than flavors, are earthy, fruity, spicy, powdery, and balsamic. Right? So we have a single chemical that when it's on the tongue, it provides certain sensory inputs. And when I sensed in the nose, I get other sensory inputs. And together, it gives me a particular flavor. So we have another 1, 2, 3, 5, 6 tetramethyl pyrazine. And I have a similar list. Aromas are musty, nutty, chocolate, coffee, cocoa, soybean, lard, and burnt, which is interesting. And the tastes are associated with nutty, musty, cocoa, drying, peanut-like raw coffee. And then there is a flavor. There is a chemical called cocohexanol, which are aldehydic, bitter. They're on the list here. I'm not going to read all of them, but you get an idea that while there are lots, going back to the previous slide, for those of you who are listening, there are over 750 distinct compounds, 25 needed for baseline aroma, 15 needed for baseline cocoa taste. You can see that how these 3 chemicals, if they're present and they're present in differing varieties, are going to have an impact on the way we perceive the flavor of the chocolate to be. If they're in the chocolate, if these are in the cocoa beans, then we need to figure out what happens through the roasting process and their presence. Right? So we've got a bunch of descriptor categories. So we use a bunch of language to talk about taste and aroma and flavor. And they were going to be acidic. We have astringent and tannic. By the way, that's a sensation. It's a trigeminal nerve sensation. It's not actually a flavor per se. Bitterness is very similar. It's a sensation. It's not a flavor. It's not a taste. We obviously have cocoa, dairy, fruity, floral, herbaceous. What we find is that these descriptors often get used, for example, in the Cacao of Excellence flavor wheel. There's a similar one for the Specialty Coffee Association flavor wheel, that what we'll do is we'll organize these into a visualization, which enables us to be able to say, this particular sample has this intensity of this flavor descriptor in it. So we get an idea that, something is very fruity or it has no fruit, something that is very floral. It doesn't have a whole lot of florality to it. It might be herbaceous and vegetal together. And so these are the words that we use to describe, at a much higher level, again, going back to the previous slide, the flavor and aroma chemicals, what they deliver to us. And I would say, looking at it now, I would say taste chemicals, not flavor chemicals. So when we reconstitute chocolate flavor, and this is the original contribution, which I learned from Peter Schieberle in a report published in 2011, is that if we think about what chocolate flavor is can be thought of as a combination of potato chips, cooked meat, peaches, raw beef fat, cooked cabbage, human sweat, cucumber, honey, and others, right? And this is really interesting because it provides a sort of higher level meta description about very, very common categories of flavors that we think about when we think about the flavor of chocolate. And what we can do from an analytical chemistry perspective is we can say, well, samples of cooked meat will contain the following chemicals. And then if we find these chemicals in a finished chocolate, we can take a look at their relative intensity to find out how they're going to contribute to the flavor of the cocoa or chocolate. So all of this is, really, really, really a fabulous kind of exercise. And I'm realizing now that back in 2012, I got taste and flavor backwards. So aroma and taste are components of flavor, not aroma and flavor are components of taste. So these slides represent a 12-year-old misunderstanding of things. But that when we think about the perception of flavor is highly bio-individual, right? And it's the result of a complex series of chemical reactions and interactions that take place in the nose, mouth, in our memory, right? And in the emotional responses that are evoked as a result of tasting, something. So we have individual sensory apparatus and differences. Some people might have more of certain kind of taste receptors on their tongue than other people do, making them more sensitive, for example, to bitterness than other people might be. There are cultural biases. I grew up in a different culture, and so some flavors are very familiar to me, and then other flavors are not very familiar to me. So part of this is, again, if you've never tasted something, you can't identify it. So if you put something in your mouth and you go, oh, it tastes, I don't know what that is, right? So that's what it is that cultural biases come in. Then you've got things like the physics of heat transfer, chewing and melting. So the way the chocolate melts in your mouth, right? The texture when you bite on it, the texture as it begins to become fluid, they have an effect. The way the fat melts has an effect on the release of flavor chemicals, right? And so things with more fat are going to release chemicals differently than if you made a chocolate from the exact same beans, right? And you added butter, cocoa butter to it, you would change the perception of flavor, in part because not necessarily diluting the flavor. I think maybe that happens. I don't know. But what you are doing is you're changing the speed at which the flavor chemicals are released. And that change in speed, the temporal component of that, is going to have a real interesting influence on your perception of the flavor. And if you are a chocolate maker, this is an exercise you want to do. Make a 2-ingredient chocolate and a 3-ingredient chocolate from exactly the same beans, roasted exactly the same way, right? And then see for yourself what the difference is, right? And it tends to be a sort of, 2-ingredient is more pure. It tends to be, there is a schism there about which side of that fence you're on. But I think it's really important that you go through the exercise and you do it in order to understand what the differences are. So we have the physics of heat transfer, and then we also have the chemistry of water and oil soluble volatiles. Again, some, for example, the sugar crystals are water soluble, and there are going to be molecules from the cocoa beans that are fat soluble. And so we can change, for example, the perception of sweetness by changing the physical size of the sugar crystal that's in the chocolate, and whether or not the sugar crystal is completely enveloped in fat, right? If it's not fully enveloped in fat, and I have larger crystals, then when I put it in my mouth, I'm going to get a much more rapid and much more intense sensation of sweetness, right? And it's possible through analytical chemistry to get rid of many of the sampling biases which are associated with the apparatus, although it is really important to understand that you have to calibrate the tools and you need to make sure that you're measuring the same thing the same way, because you could have 2 different labs measure the same beans in an HPLC column, which is calibrated slightly differently, and you'll get very, very different results. So it's really important to understand, if you ever read a paper on this, to understand what their sampling techniques are and what they control for. Anyway, I'm going to end it there for this particular part of the presentation. But in my, for the last month or so, as I've been thinking about this and working with Zoe, I am going and looking at the work that I have done over the past dozen years or more, and then thinking about what it makes sense in terms of the professional audience. Now, what I want to be working on with Zoe is work that she has been doing for a project called MoCA, MOCCA, and their flavor map. And I've got this up on the screen at the moment, right? This is the first iteration of, I don't know that this is the first, this is an iteration of the cocoa flavor guide. And it's really, really, really interesting in the sense that what it does is it presents some counterintuitive results. And this might be one of the reasons why we want to do all of the quantification that we're doing, right? So we want to be able to go and use analytical chemistry techniques to understand what the chemical structure of the particular cocoa beans that we're thinking about. And what are we going to do with that? Number one is we can take that the chemical analysis and then combine it with organoleptic or flavor analysis. So we could have a panel of professionals whose palates are calibrated, taste the exact same thing, and then tell us what they think about. And we're worried about the finished chocolate that's made from it. We tend not to consume cocoa beans so much, and we tend not to consume raw cocoa beans very much, right? But what we can do is we can go and do the analytical chemistry on the beans. We can do an analytical chemistry on the finished chocolate. And then what we can do is we can do the organoleptic analysis, and then we can try to make some comparisons. And that's one of the things that this chart does here. And it says some very, very interesting things, right? The other thing that we can do is we combine this with an understanding of the microbiology of the fermentation pile. So we might go in and say, okay, here are the dominant yeast strains, here are the dominant bacterium strains that are in the local environment, because most cocoa is wild fermented, in the sense that it's not inoculated with a known strain or strains, right? And then we can look at the relative percentage, so which within the dominant strains of yeast and bacteria, so lactobacter and acetobacter would be the two dominant families of bacteria, right, which are present in fermentation piles. We can then go and have an understanding for the way the effect of fermentation is dependent upon the strains that are in the local environment, which is really important. So what this does is if we can have an understanding of the pre-fermented chemistry of the bean, the post-fermented chemistry of the bean, the microbiome of the fermentation pile, and then we can do the analytical chemistry, the chemical analysis on for example, we might have roasted beans before it turns into chocolate, and then chocolate. So we have this continuum of samples from beginning to end, which we end with organoleptic analysis, and then perhaps tie that back to a genomic analysis. So can we look and say, all of these things can be connected to the presence of these genetic markers? And so if we want to do hybridization in the future, what we can do is we can understand the connection from genomics all the way through to analytical analysis and organoleptic analysis in order to be able to come up with a better understanding of how to deliver to a chocolate maker and the flavorist in their lab a product which is going to have the flavor characteristics that they're looking for. And this is going to be perhaps, I think that this approach is going to be complementary to what's going on here. So, I think, and, if you go through, is that Peter Schieberle is going to be giving a talk, and his talk is Understanding Chocolate Aroma on the Way from Cocoa Seeds to Chocolate Consumption, right? And so I'm looking at what it is that I just said, and I'm going, well, there's a lot of overlap there. And I don't know what Dr. Schieberle is going to be talking about specifically, right? But I think it's the application, which I'm going to talk about a little more, which I think is important. We then have Michelle O'Bonnell, who's going to be talking about the technology behind cocoa flavor. And I'm very, very curious to know what that is going to be, what technology he's talking about, and where in the process, from the genetics to the finished product, he's going to be talking about. We then have a presentation on cocoa flavor quality and artificial intelligence in the industry. So cocoa flavor quality is a really interesting concept for me. I've done a number of posts and episodes of Pod Safe Chocolate, as well as on the Chocolate Life Live, talking about the notion of quality. What is quality? I don't think there is any single objective measure of quality. Quality is subjective. It's a basket of attributes, and it represents basically what we're willing to pay for, right? I'm willing to pay for this and not that, right? And so the definition of quality is tied up in consumption habits. And so I'm really interested in understanding what they think of with respect to cocoa flavor quality. Is it intensity? So I am really going to be fascinated to be in the room, right? Because I think this is going to be a really, really exciting presentation, and I'm looking forward to learn a huge amount during the course of the day. Then my contact, Andrea Albertino, who is the honorary president of the British Society of Flavourists, and he's the one who asked me to participate last year and this year. So is going to be giving a presentation, which is, have you thought about using these chemicals, right, in a chocolate flavor? And so here is where I think I might have some bias about what it is that a flavorist does, right? Which is that a flavorist says, a flavorist is tasked, right, as a part of their job with being able to deliver a certain flavor experience to customers when they consume a certain product. And perhaps one of the questions is what can we do to modify whatever flavor naturally occurs in whatever it is we're making? So what are the naturally occurring flavors in the chocolate? And what we want to do is we want to enhance that experience or change that experience in some way. And what can we do in terms of adding natural and artificial flavors, right, in order to be able to achieve that target? And, is that what a flavorist does? And that may be my bias here in terms of not fully understanding what it is that how the flavorists see their roles in their companies. And so, for me, that's, in the morning coffee, welcome coffee, the evening before, during dinner, during the coffee break, or during lunch, to get a much better understanding, or even just asking the question, to one of the presenters, what is she doing? But really, really, really very interesting. So these are the presentations that are coming in front of me. Now, because these people are coming in front of the presentation that I'm giving with Zoe, now because I am assuming that every single person in the audience, is familiar with the tools of analytical chemistry, right? That when it comes to quantifying the flavors of cocoa and chocolate, that's not something we need to do. I don't need to tell people how HPLC works. I don't need to tell people how near-infrared analysis might work. I don't need to tell anything about that, or organoleptic panels. What I want to focus on, right? And again, I really wish that, I don't have an email for Dr. Schieberle, and I wish that I could get his presentation in advance, so I know exactly what it is I'm talking about. I have to talk to Andrea to see if I can. I want to make sure that I'm not duplicating what it is that, or I want to make sure Zoe and I are not duplicating what it is that he's saying. All right. But if you have any questions about any of this, and I'm using terminology you don't understand, what are the kinds of things that you'd like to see? I mean, I'm planning to do an episode of Pod Safe Chocolate after this is done, so that what I can do is I can share what it is that I learned. And so, if you've got some questions or you think you'd like to know as a part of the experience, I would really, really love to know. So what I'm going to do is I'm going to go down and I'm going to go take a look again at this, cocoa flavor guide visualization. And I'm going to walk you through what I think is important about it and why I think it's important to quantify the flavors of cocoa and chocolate. As one goal, this is not necessarily the only goal, but I think it is a very, very useful goal. So one of the things that the Mocha Flavor Map, so it's a joint effort between Mocha, which is maximizing opportunities for coffee and cocoa in the Americas. It is funded in part by LWR, Lutheran World Relief. This work was done in collaboration with the University of Copenhagen, and there are other organizations that are involved in this. But if you look at this, what you'll do is you'll see we have two axes. The vertical axis at the bottom is labeled caramel panela, and the top axis is the positive axis is woody, right? If we look at the horizontal axis, the left side of the axis is cocoa, and the right axis is acidity. And what we see is that the researchers here have identified a couple of clusters, right, where there appear to be cocoa beans that are grown in different countries, where they have different fermentation protocols, right? So we have different genetics and different fermentation protocols, obviously different agronomic practices. And what happens is they deliver remarkably similar flavor profiles. And what's interesting about one of these is that it is the one labeled dynamic on this chart when you go look at it, right? If you're just listening. The three areas that are identified are nutty, aromatic, and fresh. And the third one is dynamic, as I mentioned. And the dynamic has a cocoa component and an acidity component, as well as this caramel panela component. And what we do is we find that there are representative beans from Nicaragua, Peru, Ecuador, and Guatemala. I believe all four countries are in here. And what we've got then is what this suggests is that I could take beans from any of the cooperatives, which is represented here, and create a very, very similar tasting chocolate. And so this could be a guide to blending, right? Which would be interesting. I'm looking to be able to do a blended chocolate. I've got a bunch of opportunities from within, a bunch of options from within Peru. So Gran Blanco, Cordillera Colán, Huamicuña would be another. Or if I've got Guatemala, it might be Kawa Cacao, Ipole, or Sots. I mean, these are names which are on the chart here for people who are listening. But I have an opportunity. So what I might do is I might say, I can go and do a blend of beans from a single country, right? Or from different countries, right? And be able to make a chocolate that is very similar. Or, if I've got a place and they don't produce enough beans and I need to get more beans and I want to I'm not really worried about the single origin-ness or, making sure that, it's always the same single origin, again, blending, which is not a bad thing, right? Then what I could do is I could go, the Gran Blanco in Peru, which is up in the north, in Ecuador and Piura, I believe that the Piura Gran Blanco, and the Cordillera Colán, I could get those beans, and if I can't get enough from one, I can go to another, get more beans, and now I would have enough beans to be able to produce what it is that I need to produce and not have to spend a huge amount of time in recipe development. So understanding different roast profiles and things like that in order to be able to deliver what it is that I'm looking for. And I think that's a real interesting aspect of this. So I can go up into aromatic and fresh fruit. And what I do is I find that I've got some beans from Ecuador. Whoops, excuse me. I've got some beans. I'm sorry, I'm stuck in a UI thing here, if you're listening. I've got some beans from Ecuador. So the Rio Alambi, and someplace in Peru called Utku. And I could put these things together and put beans from both of those places together. They're closely related to each other, and I would be able to create a chocolate which had very, very similar chemical characteristics. And again, I think this is one really, really interesting goal for quantifying the flavor of cocoa and chocolate, right, in a systematic way. That we can do the analytical chemistry on the wet seeds before fermentation, the analytical chemistry on the fermented seeds before they're dried, the analytical chemistry on the dried beans, and then the chemistry on the roasted beans. And then we can understand how the chemicals are transformed, right, from the raw state to their roasted state. And then we could go and take a look at the genetics of the cacao, right, and understand what correlations there might be between which places on the genome seem to be responsible for certain flavor loci. That would be very interesting. The final step, of course, is to be able to correlate that with organoleptic or sensory analysis. So we need trained tasters who have calibrated palates and experience, who can go and taste these things. And it's really, really important when we go take a look at the way the cacao of excellence is formulated, that while they award cocoa beans, right, and so what they're doing is they base the analysis on transforming the cocoa beans into chocolate. So there is an analysis of the cocoa beans, which is done to say, okay, there are obvious defects in these beans, which we can taste as trained tasters. There are obvious defects here, which suggest that some post-harvest processing and some agronomic work needs to be done to improve the health of the trees and the post-harvest processing to get rid of these defects. Right. The finalists who make it through that initial bit of triage then have their beans converted into chocolate, and the final analysis is done on the chocolate. So these beans make this chocolate, and we think this chocolate is exceptional, and therefore we're going to award the beans used to make this chocolate, right, in the cacao of excellence, is either gold, silver, or bronze. A similar methodology is made in the Heirloom Cacao Preservation Project. So what they do is somebody presents beans. The beans are assessed and say, we think these are interesting beans. And if we think they're interesting beans, what we'll do is we'll go to the next stage and we'll make chocolate from them. Right? They will go and do the analysis of the genetics of the beans after the decision has been made that this makes chocolate, right? Because they're interested in the properties that make exceptional chocolate, and then they'll do the genomic analysis and they'll understand what the parentage and the mix of parentage is for that particular set of beans, right? And so this is very, very cool. This is really, really fun understanding of what's going on here, and I think it's a real interesting way to think about quantifying the flavor of cocoa and chocolate, because in the abstract, I really don't care about it. I mean, if I'm a research chemist, I need to publish reports. And so in the abstract, I understand why a research chemist might want to do it. For me in chocolate, it's connecting, I want to understand why this chocolate is an exceptional chocolate. So I want to start from there. This is a great chocolate. Can we figure out what aspects of the process went into making this a truly exceptional chocolate, while another chocolate, maybe from beans from 100 kilometers away, made in a factory just down the street, tastes entirely different and doesn't have the same characteristics that that most people would appreciate. That's really, really interesting. getting back to the genomics, understanding the genetics in detail helps us guide hybridization. So we can much more quickly understand when we do the crossbreeding of plants, whether the characteristics that we're looking for, right, have taken into the third generation. If I have to wait for trees to grow to maturity to grow pods, and then make sure that the pods are in fact pollinated with specific pollen from specific donor trees, then it can take 15, 20, 30, 40 years or longer in order to be able to say, I've got a trait that I like and that trait is breeding true. And now I've got some other trees and I can start grafting from there, right? If you can do it at the genetic level, so genomic testing, and understand through what are called taking SNPs, single nucleotide polymorphisms, understand the genetic structure, what you can then do is go and while the tree is immature, you can say whether or not, you can say much more quickly, often, with multiple generations within a year, you can understand whether or not a particular characteristic has set in the tree. And therefore what you can do is you can start propagating the trees which have the characteristics that you look for that will be passed down to future generations of trees, and you can start propagating those trees. And so those are the interesting things for me. But for a flavorist, right, what I think, because I'm not a flavorist, and my co-presenter Zoe is also not a professional flavorist, I think what we want to do, I think the direction that we're leading towards is, what is it that is being done to be able to deliver to the flavorist, right? Cocoa and chocolate, which meets specific characteristics. And so that there is a better understanding of the practices which are going on, research institutes all over the world, in order to be able to do these things. Now, again, right, this is not my presentation to the British Society of Flavourists. I just want to let everybody know this is not what I'm going to be presenting. It's not what Zoe is presenting. We're going to be working on this together over the course of the next 6 to 8 weeks. It's summer holiday season in Europe, and Zoe is located in Belgium. And so I think she's on holiday today. So when she gets back from holiday, we're going to be going in, we're going to be into a much closer collaboration. We have about 30 minutes to give this presentation. I've already spent an hour. We have about 30 minutes to make a presentation and leave roughly 15 minutes for questions. And it's going to be a real interesting challenge, I think, for both of us to be able and cut this down and focus on what it is that we really think is important that a professional flavorist know about this. And I think that's the point. What do we do? And, and that's why I'm interested in your thoughts, in the comments. Let me know, a live chat on YouTube, the comments and other platforms. If you are a Chocolate Life member, you can scroll down to the bottom of every page, and there's a member discussion box. You have to be logged in. You do have to be a member, free member, premium member, doesn't matter. Notice that I put at the bottom of today's page that if you are a free member, there are 2 special offers for 2 months free membership, right, up the front. So you can save yourself between $10 and $30 a year on a monthly membership. If you go for an annual membership, you save even more. But I just wanted to give everybody that heads up. There are also links on the post to the archives for PodSafe Chocolate, the archive for the Chocolate Life Live, as well as the new audio podcast on Podcast. So you can click on any of these links and get your fill of hearing my voice. I also want to let you know that there are 2 files which I've included, which I haven't shown. Now, one of the things that I've mentioned and I want to provide reference to is this paper, which was published in 2008 by a team led by Juan Carlos Montemayor. It's called The Geographic and Genetic Population Differentiation of the Amazonian Chocolate Tree, Theobroma cacao. It's published in October of 2008. And this is important for me, right? Or it has relevance in my life because my book, Discover Chocolate, was published in October of 2007. And I presented the classic, Criollo Forastero Trinitario triumvirate. And this paper just blew it out of the water. So it holds special place in my heart. And I got a chance to share that story with Juan Carlos once when I met him at a symposium at Penn State University, Frontiers in Cacao Science. And what it will do is it shows here's the results of genetic research, which suggests that there are two main families of cocoa, the Criollo family and the Forastero family, and that within the Forastero family, we have clusters of many different varieties. So Amelinado, Contamina, Curare, these are distinct varieties. So again, Nacional is a variety of Forastero, just for everybody who wants to know. There has been more work done since this, and I've talked about it, which identifies much more closely the origin, the geographic origin for Criollo. But what I have done is I have uploaded the Montemayor paper to the post for today. So if you are interested in downloading that post and taking a look, or downloading the paper, you can download the paper. I've also uploaded the spreadsheet, which I showed earlier, on the chemistry of cocoa. Again, I don't remember the source for it. Unfortunately, if I did, I would certainly acknowledge it. This was like, I've had it since at least 2012. And I didn't think to embed into the spreadsheet what the source was. But if you are interested, those resources are there. In addition to the images of the flavor guide for mocha, as well as the 6 images from my 2012 presentation on how chocolate gets its taste. And with that, we're at the end of the hour. I want to thank everybody who's been here from the beginning. People who popped in and popped out, thank you very much for joining me today. Like the video if you found it interesting. Subscribe to the channel. Hope to be able to get to the 1,000 subscriber mark before the end of the year. It'd be really great if we could do that. Right. To remind everybody that this episode of Pod Save Chocolate, like every episode, is sponsored by the members. Don't do Patreon, not taking advertising. Your support is what keeps this going. So please go to thechocolatelife.com, sign up for membership. There's always a free membership. And again, I appreciate financial support if you can do that. And before I head out, what I want to do is I want to just an update. I've been wanting to do single sign-on between thechocolatelife.com and the archive site. And it's been working on it for a while. I had hoped to be able to get it done in the month of July, and if not, in the month of August. But my developer is in Bangladesh, and if anybody's been paying attention to global politics over the last couple of months, there's been an insane amount of unrest in the country of Bangladesh. The president stepped aside. There's some really questions about what the next elections are going to look like and who's going to come in and take power. Part of the unrest has led to widespread and intermittent outages in internet connections and maybe government censorship of common social media channels, things like WhatsApp, for example, and other messaging apps are just being blocked at the border. So because my developer lives in Bangladesh and has been caught up in all of this, it has been a challenge, as you might imagine, to get things done. So I want to let you know that I am still working on it. I'm hoping that you can be logged into the Chocolate Life, and then when you go over to the archive site, you're seamlessly logged in. You don't have to create a new account, nothing like that. It will just happen for you. And then not only will you have access to all of that content, but I'm going to be focusing on making sure that the forums are going to be fully active. And so the kind of free-flowing exchange of information which had been available is going to be available in the archive or the new site. It'll be the forum site, not the archive site, but it will be active. So I want to let you know that this is something that I have been working on. We are working on it, but it's been taking a little longer just because of global politics. And with that, still try to have a smile on my face and enjoy what it is that I'm doing, because as you know, if you're working with chocolate and you're not having fun, you're doing it wrong. Until the next time, everybody, ciao.